So, in the Faroe Islands, the sea lice species that affect farmed salmon are the salmon lice and the Caligus elongatus. Salmon lice are also found on the wild trout swimming around the islands, and the abundances in the areas typically relate to the farming activity. So we have salmon lice throughout the year. For the Caligus elongatus, they have been found on more than 80 species, and they typically show seasonal abundances, and this is also the case in the Faroe Islands, where they are most abundant during winter and practically absent during the summer. Both these species now have three planktonic stages, the two now-play stages, and the infective copeptide. So we have monitored the planktonic stages in the Strait Sundaleie, in the northern part of the Strait Sundaleie, for more than 2 salmon production cycles. And we have sampled 4 stations approximately fortnightly. So the samples have been taken with 150 micron plankton net, which was towed just below the sea surface for approximately 200 meters. So altogether, this data set has 240 samples. But during this time, there has been quite a lot of changes in the production of salmon. In the first production cycle, there was an additional farming site in the Sundaleie. And between the second and third, the sea lice limit, the limit for salmon lice was reduced from 2 to 1.5 per adult lice per fish. But we have not been able to detect these changes in the abundances of the planktonic species, of planktonic stages. The planktonic stages, they covariate with the amount of lice on the fish. And for the salmon lice, they're most abundant in the second year of production. And for the Caligus, they are most abundant in winter, but not every winter. For example, in 2016, there were almost no lice. And also in the last winter we sampled, there were plenty of lice in the planktonic stages, but none on the fish. And this is because of delousing activity. So if we look at the statistics, there is a linear relation between the production of salmon outplay and the planktonic stages in the sea. And this is valid for all the stations we have sampled, but a larger portion of the variance is explained at the station closest to the fish farm. For the Caligus, we don't have the temperature-dependent production, so here we just compare the number of adults on the fish, and again we have linear relationships between the fish and the planktonic stages. And again, we have the most of the variance is explained closest to the fish farm. If we then look at the spatial distribution of the planktonic stages, it's actually not close to the fish farm where we find most lice, but at the station which is farthest away. And this is contrary to most samples where the stages are dominated by now-play, because most often now-play are really close to the fish farm and then they disperse away. But in this data set, the planktonic stages are dominated by the copeptides. And the prevalence in the samples is quite high for the salmon lice during the active production, while it's a bit lower for the Caligus elongatus because this has this seasonal variation. So if we want to find out why we see this strange distribution of the sea lice, we have to look at the seawater circulation in the area. And this is this study basin. This is quite long and narrow. And at the entrance to the north, there is a sill. And the tidal sea level variation is up to 2 meters. South of the basin, there's also a sill. And there the tidal variation is much less. And this is because we have an amphidromic point somewhere near here in Torshavn. And these features, they make the seawater circulation quite distinct in this area. And this has been modeled by Spatial and others. And they found that even though if we look at an hourly basis, we have the water flowing north and south through the sound. If we then look at the long time residual currents, then we have kind of two states of the area. The first period, the area is kind of like a fjord-like state, while the second period, resembles a strait. So in the first period, we have water flowing in at the bottom through the northern sill and flowing out again at the surface water at the northern sill, and then we have an additional flow from the southern shell. While in the strait-like state, we have just water, the residual water is flowing south through the area. And this implicates that the seawater resident time is longer during the fjord-like state. We haven't modeled the entire period where we have investigated the planktonic stages, but we can approximate the model by looking at the sea level height north of the strait and south of the strait. And if we only take the samples where the fjord state is clearly strait-like or clearly fjord-like, and if we also take into account if the seawaters were flowing north or south during sampling, then we find a correlation between the sea lice numbers at station 4, which is close to the strait, so southern sill, and the fjord-like state, and the state of the fjord, and the state of the sound. So when we have the fjord-like state, there are more sea lice in the area than when we have the strait-like state. This is very preliminary, and we're going to investigate this further. But one of our hypotheses is that when we have the strong strait-like flow, the sea lice flow over the sill and away from the area, while when we have a weak strait-like flow, they kind of pile up just before the sill, and that's why we have these high numbers on station 4. We have also looked at the depth distribution of sea lice, where we have pumped water from 1 to 40 meters depth, and for each sample we have filtered 32 cubics of water. This was done for 2 stations in January and 2 stations in October. In January, we were in the Sundalei Norður, but in October, we investigated Sundalei Sur because there was no fish farming activity in Sundalei Norður at that time. In the 2 weeks in January where we sampled, there were a lot of changes in the sea lice abundances. There were quite a lot of sea lice in the beginning, but at the end of the sampling, there were almost no lice in the sample. And this is probably because there was a delousing in the area some days before we started sampling, and at the end of the sampling, they had diluted away or died off. In the southern case, which we sampled in October, the temporal variation aren't that prominent. If we look at the vertical temperature differences, the temperature only increases 1 degree during the sampling in January with depth, and in October it increases half a degree, and also the salinity is quite stable. So most of you would say that this is kind of a sampling in mixed water. And in this scenario, the abundances of salmon lice copepodite is as expected. We have most copepodites at the surface, and the abundances decrease with depth. But we still find copepodites at 40 meters depth. For the Naupli, we didn't have that high numbers, but there was a tendency towards higher numbers at depth than at the surface. And if we just look at this with a linear model, we see that that the Naupli numbers increase significantly with depth, while the copepodites, they decrease with depth. So for the Caligus elongatus, we have an additional station, We have also sampled in Sørvágur, and also here we also present the adults. And this is because we also found adults in the planktonic samples, but not in high numbers. And for all the stages, they increase quite significantly with depth. And for the naupli and copeptides, the increase is significant, but for the adults, we don't have that many high numbers, so we can't see significant correlations. But still, we don't find any adults at the surface while they're present at depth. And one other thing which is quite interesting about the adults is that we almost only found males in the planktonic samples. So if we look at all these stages and both species, it's actually the salmon-like copeptides that show a different behavior from all the others. So in summary, the densities of both species relate to the amount of adults on the farmed fish. And for the Caligus, this is because the number of adults and naupli covariate, and it's the seasonal changes that are the driver. So in our data set, the copeptides dominated the stages, and we found highest abundance farthest away from the farm, which was close to the sill. And we have found some relation to the hydrographics of the area, but we will investigate this further. And for the depth distribution, we found that the copeptides, they have higher abundance at the surface, which is also what is the general assumption. And all the other stages showed highest abundance at depth. So thank you for your attention.